We'll see a problem on method of sections today. How to calculate forces in the members for a truss. Yeah, method of sections. So it is a process used to solve for the unknown forces acting on members of a truss. So whenever on a truss, whenever there is a load acting, there are some loads here. You can see horizontal and vertical loads. So due to these loads, forces will be generated in the members of the truss. So we need to calculate these forces. So here, method of section. In this method of section, so there are two methods: method of joints and method of sections. There are two methods to calculate the forces in the members. But when to use method of joints and when to use method of sections? So if in the question he is asking to find the forces in all the members of a truss, then it is better to go with the method of joints method. Method of joints. So if he is asking for the particular members, forces in particular members, like in this question he is asking find the forces in the members DF, DG and EG. So if he is asking for a particular member, then we'll prefer method of sections. So this method involves breaking the truss down into individual sections and analyzing each section as a separate rigid body. So in this method, we'll break the truss into individual sections. So let me explain this clearly by taking the example problem. So find the force in members DG, DF, DG and EG. This is the question. Height and spans are given here. A, B, C, D, E, F, G, H are the joints. You have horizontal and vertical loads here. Right. So first of all, we are removing the hinged support and roller support, and we are showing the reactions here. For hinged support, you have two reactions. For roller support, you have one reaction here. This is the free body diagram. Now, step 1, find the reactions using the equilibrium equations. So in both the methods, method of joints and method of sections, the first step is to find the reactions. These reactions 1, 2, 3 using equilibrium equations. Sigma fx equal to 0, sigma fy equal to 0 and sigma moment equal to 0. So applying sigma fx equal to 0 here. So RAH plus R20 equal to 0. Next, sigma Fy equal to 0. So RAV upward force, if we take upward force plus and downward force minus, so RAV plus RH is equal to, RAV plus RH minus 10 minus 15 minus 10 equal to 0. From here sigma fx equal to 0, you will get RAH as minus 20. So next equilibrium equation is sigma moment equal to 0. So we'll apply sigma moment at about A equal to 0. So from this we have one force 10 into perpendicular distance, 15 into perpendicular distance, 20 into perpendicular distance, 20 into perpendicular distance, and this 10 and RH. So anti-clockwise will take positive, anti-clockwise will take negative, clockwise positive, anti-clockwise negative. So 10 into 10, this one, 10 into 10 clockwise, so plus 15 into 20, 15 into this distance 20, so clockwise plus 10 into 30, 10 30, 10 distance 10 10 10 30 clockwise. RH is acting anti-clockwise. What is the distance? RH. So RH value is minus RH into 40. So total distance is 40. And one more thing, this 20 is there. 20 into perpendicular distance. What is this distance? This height. So height you have as 10. So 20 into 10 clockwise. Right. From here you will get RH equal to 22.5 Newton. And substituting this value here, you will get RAV. So from here, from step 1, we have got all the reactions. Next, step 2, cut the section 1 1 as shown in the figure. So as he is asking to find the forces in these members, we need to choose the section such that the section is cutting these three members. Here I have cut in this way because he is asking to find the forces in these members. This section is cutting these three members. Right. Now we can choose either left side portion or right side portion. As the left side portion is looking smaller, so it will become easy to analyze. So I am taking right side portion here. Yeah, let us consider the right side portion of section. This is the right side portion. Here you have FDF, FDG and FEG forces in these members. See, I am taking away from the joint. Away from the joint. Right. Now what I am doing? I am converting this inclined force into horizontal and vertical component. Horizontal, here you can see horizontal and vertical component. For this I need this angle. So how to find this angle? As the height is 10 and this base is 10. So tan theta equal to 10 by 10. So theta equal to tan inverse 10 by 10. Theta equal to tan inverse 1 equal to 45 degrees. So if dg cos 45, if dg sin 45. Now we need to apply the equilibrium equations for this right hand side portion of the section. Now using this sigma fx equal to 0, sigma fy equal to 0 and sigma moment equal to 0, you can find the forces in these members. So first I am applying sigma fy equal to 0. So upward forces minus downward forces is equal to 0. So upward force FDG sin 45 minus 10. Again you have upward force here RH 22.5. So plus, from here you will get FDG as minus 17.66. So minus, therefore compression. Right. Then I am applying sigma moment about G equal to 0. See, remember here we have to apply equilibrium equations for complete the right hand side portion, not joint by joint. Right. So sigma mg equal to 0. FDF into 10, that means this force into perpendicular distance, as it is anti-clockwise, minus FDF into 10 plus 20 into 10, this height is 10, right, minus, this is clockwise, so plus, and this force we have, right, 22.5. Minus 22.5 anti-clockwise, so minus 22.5 into, what is the distance? 10. So from here you will get FDF as minus 2.5 Newton, minus therefore compression. So we have got this one and this one. Now this is balance. So I will apply sigma fx equal to 0, one more equilibrium equation. So applying the sigma fx equal to 0, so right side force equal to left side force. From here you will get this one, or here I have taken if we take right side force as plus and left side force as minus, so first this force is there now, so left side, it is going left side, so minus FDF, and one more thing, what you have, minus FEG, minus FDF, minus FDG cos 45 is equal, plus 20 is equal to 0. From here you will get FEG equal to 35 newtons. So plus, therefore tension. That's it. We have found out all the forces in the members which he has asked in the question. Then I am representing them in the form of a table. So serial numbers, forces in members FDF, FDG and FEG, their magnitudes, and if it is minus, compressive nature, minus compression, plus tension. If you want to show in the truss these forces, you can show in the truss like this. So FDF is minus 2.5, that is FDF. So FDF, okay. So 2 point compression. Therefore compression means we have to take towards the joint. Therefore towards the joint. So towards the joint. So this is In this way you have to show the compression. And here FDG minus 17.67, that is compression. Compression means towards the joint. So this is 3.5 tension, FEG or FGE. So tension means away, you have to show away from the joint. Right. So what we have done here, in method of sections, we have to find the forces in these members using the method of sections. First step is to calculate the reactions using the equilibrium equations. We have got the equilibrium equations. This step is same for the method of joints also. First step is same for method of joints and method of sections. Right. Next, in second step, what we will do in the method of joints? What is the second step? We will select a joint which has two unknowns only. From there we will start. We will go the joint by joint and we will draw the free body diagram at that joints. In that way we will calculate the forces. But here in this step, the second step is, in this method, the second step is we will cut a section in this way, such that it cuts the members in which we need to find the forces. Then after cutting, we can take either left side portion or right side portion. I have taken here right side portion so that the analysis will be simple here. And for this whole portion, I am applying equilibrium equations and I have found the forces in these members. I have shown in the table and on the truss also, compression and tension. Yeah, there ends the problem. So what is the basic difference between method of joints and method of section? When we will use these methods, if we need to find the forces in all the members, then method of joints is used, and if we need to find the force in particular members, then method of section is used. That's it. Thank you.